Hey guys, and welcome back to Miss Chemistry, and today we're going to go through acylation. If this video helped you with your revision, please like and subscribe. And the checklist is in the link down below in the description. So acylation. What we need to know is the structure of acyl chlorides. Now acyl chlorides has a C double bond O and a chlorine. And the C double bond O is our acyl group, and then we have our chlorine, which makes up the acyl chloride. And if we want to naming our acyl chlorides, so can you guys name this acyl chloride? Well, you need to count the longest carbon chain, which there's 2 carbon atoms, and the C double bond O with the chlorine at the end, so it's definitely an acyl chloride. And there's 2 carbons, which means it's an ethan. And when you're naming an acyl chloride, the ending would be ending in OYL, oil. So it'll be ethanoyl chloride. And if there's 3 carbon atoms, it'll be propanoyl chloride, etc., etc. And we need to know how to name amides and the structure of amides. So amides has a C double bond O but with an NH2 at the end. The same as an acyl chloride, but without a chlorine, just an NH2. And this name would be ethanamide because there's 2 carbon atoms and there's a C double bond O with an NH2, so ethanamide. And then we need to know about our acid anhydrides. So they look like this. So they basically have 2 C double bond O's, and they have basically an ester forming. So they look like this. And naming acid anhydrides, so obviously acid is at the beginning and anhydride is at the end. So if you're naming this, for example, we count the longest carbon chain. So there's 1, 2 carbons. So there's carbons for like each section, you know, after the oxygen. So therefore it will be ethanoic anhydride because there's 2 carbon atoms and there's an anhydride. So yeah. So acyl chlorides are the best acylating agents. Okay, they're the go-to ones. Acyl chlorides are the best acylating agents. So here's our acyl chloride, and I'm going to show you why they are the best acylating agents. Well, this carbon is delta plus, it's positive, and the chlorine is delta negative, it's electronegative. The chlorine is electronegative, meaning that the chlorine attracts the shared pair of electrons. They are pulled towards the chlorine, and the chlorine is attracting those electrons. So therefore the chlorine becomes more electronegative, making the carbon more positive. Okay, so now we have our 4 nucleophiles. The 4 nucleophiles you need to know for acylation, and this is quite easy, so don't worry guys, okay? So we have our water. Water has 2 lone pairs of electrons because it only has 2 bonds with hydrogen. Remember, it needs 4 bonds, but here it has 2 bonds of hydrogen, so therefore it has 4 pairs of electrons ready to form a bond. Same with the primary alcohol. Ammonia has 1 lone pair of electrons, and a primary amine is basically the same, 1 lone pair of electrons. However, a primary amine is a better nucleophile than ammonia because the lone pair of electrons on the nitrogen is more readily available than the lone pair of electrons on ammonia, because the primary amine has 2 bonds with hydrogen, whereas the ammonia has 3 bonds with hydrogen. And this is the same for the primary alcohol, which is the primary alcohol is a better nucleophile than water, as the lone pair of electrons on the oxygen are more readily available. And this goes from weakest to the strongest nucleophile. In the exam, they're not going to ask you to compare these. They're probably going to ask you to compare which one's the better nucleophile between primary amine and ammonia, and between primary alcohol and water. They probably won't ask you about for the weakest to the strongest, but I thought it will let you guys know. So the acylation mechanism is called nucleophilic addition elimination. And acyl chlorides. So acyl chlorides conditions are room temperature. They don't use a catalyst, meaning they have a high yield, so it's very, very expensive. And it always produces hydrochloric acid, so it's very corrosive, and it produces a toxic gas, which is hydrochloric acid. So that's when an acyl chloride always undergoes nucleophilic addition elimination. And then you have our acid anhydrides. Their condition is that they use heat and they use concentrated sulfuric acid, but however they produce a low yield, so it's more cheaper, and it always produces a carboxylic acid, so therefore it's less corrosive and less vulnerable to hydrolysis, and it does not produce a toxic gas product, just unlike acyl chlorides. And those are like the industrial advantages you need to know about acid anhydrides, which is what they would ask you in the exam. Now we're gonna look at how the nucleophilic addition elimination mechanism works. So first we have an acyl chloride with water. So obviously there's a lone pair of electrons on the oxygen in the water, and these lone pair of electrons are attracted to the positive carbon, the delta plus carbon, and those pi electrons then pulled towards the oxygen, which is very electronegative, and therefore the bond breaks, the double bond breaks. So therefore this double bond is broken, so the oxygen gains these lone pair of electrons and becomes negatively charged, and it forms a single bond, and then the water attaches to the carbon and the oxygen becomes positive, and then obviously there's the chlorine. So then the oxygen with the lone pair of electrons and is very electronegative forms a double bond between the carbon. So these lone pair of electrons are attracted to the I think it's sigma electrons, and then it wants to form the double bond, and then since the oxygen that just attached, that's the oxygen that just freshly attached to the carbon, the hydrogen is then attracted to the hydrogen is gonna break off. So the bond between the oxygen and the hydrogen breaks, and then the bond between the carbon and the chlorine breaks as well. So therefore this produces HCl, because remember acyl chlorides always produce hydrochloric acid, and this is because the hydrogen ion and the chlorine ion are removed. They're broken off of this compound, so it produces hydrochloric acid, meaning that the remaining is the ethanoic acid. So it produces because it forms a C double bond O, and it's just the oxygen and the hydrogen left, so it's a carboxylic acid, ethanoic acid. Now water with an acid anhydride, so it's basically the same thing, it's just an anhydride. So same lone pair of electrons attracted to the positive carbon, double bond breaks because the pi electrons are attracted to the very electronegative oxygen. So then oxygen gains these lone pair of electrons, becomes because negatively charged, the water attaches and the oxygen is freshly attached, so it becomes oxygen is very positive, and then obviously we have the rest of our acid anhydride at the bottom, and then those are our 3 hours, and then the hydrogen ion is removed and it's gone off to, so we know that the CH3 C double bond O and the O from the arrow below that carbon is broken off. This is broken off, and therefore this oxygen has a lone pair of electrons, and this hydrogen ion, which is removed also, is attracted to this lone pair of electrons, so it forms a carboxylic acid, so ethanoic acid, and it produces another carboxylic acid because the remaining compound is there, so ethanoic acid. So now it's your turn, guys, to draw the mechanisms. I know, very annoying, but you guys need to know how to draw it. When you get used to drawing it, you'll just know immediately. So I want you guys to try, and I want you guys to write the equations also for these. So these are the answers for number 1. So you can pause and look at if you got these right. And then number 2 is this. So also what I wrote in red, it's optional. You don't need to write that in the exam, but it just shows further understanding that you know what you're doing. So yeah. And then number 3, oh oops, that was not meant to be number 1, but this is number 3. And yeah, and also methanoic acid is very important, because methanoic acid is the only carboxylic acid that can be oxidized, as it also has an aldehyde structure, because we all know that aldehydes are at the end of a carbon chain. The C double bond O and the H is at the end of carbon chain. So methanoic acid is the only exception, and when it's oxidized, that means there's an oxygen being added to the molecule, so it forms this. So it forms carbonic acid, which can be decomposed into carbon dioxide. So I hope you guys found this video helpful, and guys, make sure to practice all those exam questions, everything. I recommend PMT. Do